Hello friends, in this video let us discuss about the differences between your slip ring induction motor and squirrel cage induction motor. So if you look at the basic conception of slip ring rotor and squirrel cage rotor, because the three-phase induction motors, depending on the type of rotor used, they are classified into two types. One is a slip ring type of induction motor and the other one is squirrel cage type of induction motor. Now, based on these two rotors, our induction motors are classified, and if you look at the very basic construction of these two rotors, this is your squirrel cage type of rotor and this is your slip ring type of rotor. So, if you are employing squirrel cage type of rotor for your motor, then it is referred as squirrel cage type of induction motor, and if you are employing slip ring type of rotor for your induction motor, then it is referred as your slip ring type of induction motor. Now let us discuss the basic differences between these squirrel cage type of induction motor and the slip ring type of induction motor. So generally in slip ring type of induction motor, the construction is complicated. You are having the complicated construction because of the presence of slip rings. So if you look at the parts of the rotor which is used for slip ring type of induction motor, here you are having three slip rings, and here this green part represents your carbon brushes. So the construction is complicated because of the presence of the slip rings and the brushes, and here the construction is simple and rugged. And in slip ring type of induction motor, the rotor is wound for the same number of poles as that of stator, but in squirrel cage type of induction motor, the rotor itself automatically adjusts to the poles as of stator. Here it is automatically gets adjusted to the poles of stator. And generally in squirrel cage motors, mostly the three-phase windings are wound in stator. That is wound in stator are delta connected, because mostly the starter used for your squirrel cage type of induction motors are star delta starters. They are star delta starters. Hence, the stator of your squirrel cage type of induction motor is delta connected. So, for both the type of motors, that is squirrel cage type of induction motor and slip ring type of induction motor, the stator part is same. So, the parts of the stator are same, but only basing on these two rotors, we are classifying the induction motors, and the stator is remaining same for both these motors. But depending on the type of starter, the windings can be delta or star connected, and mostly for squirrel cage type of induction motor, we are going for star delta starters, and hence your stator is delta connected to reduce the high starting currents. And for your slip ring type of induction motor, as the starting can be done by employing external resistances. So hence your stator can be either delta or star connected. And in slip ring type of induction motor, as the name suggests, the slip ring, the rotor windings, are permanently connected to the slip rings. They are permanently connected to the slip rings, and here if you look at the squirrel cage type of motor, the slots are slanted in order to prevent the magnetic cogging, or that is, you say, magnetic teeth locking between the rotor slots and the stator slots. So they are slanted, that means they are neither perpendicular or parallel to the axis of shaft. They are oblique in angle. So this is your shaft, and here are your bearings to support the rotating shaft, and this is your end ring, and here are your slanted slots, and on those slanted slots we are using aluminium, brass or copper bars. copper, you can say copper conductors or rotor bars. Now, the slots are slanted in order to reduce the magnetic humming noise and in order to overcome the effect of cogging and for the to avoid the stalling of motor, the slots are skewed and the conductors are placed in that skewed slots. So here the conductors are skewed, that is the slots are skewed, and in the skewed slots we are using our conductors. And here if you see, we are employing both slip rings and brushes to connect the external resistances. Here no slip rings and brushes. So external resistance can be connected to your slip ring type of induction motor. Here as the rotor bars are permanently shorted with the help of end rings. So here are your end rings. As the rotor bars are permanently shorted at the end with the help of end rings, there is no possibility to add external resistance. No external resistance. Now this external resistance helps in achieving high starting torque. High starting torque, and here moderate starting torque, and it cannot be improved because we are not having any resistance, external resistance here, and this cannot be improved. So because of the presence of the external resistances which are star connected here through the slip rings and the brushes, we can go for a good speed control in your slip ring induction motor. So we can have a better speed regulation or speed control, and here speed control is not possible. And if you, because of the presence of the slip ring and brushes, the construction is complicated and frequent maintenance is required. We require frequent maintenance because of the sparking which is taking place in the brushes. We require frequent maintenance, and here less maintenance is required. Less maintenance is required, and because of the presence of the slip ring and brushes, that your slip ring type of induction motor is costlier. It is costly, and as the construction is very simple here, the robust construction is seen in the squirrel cage type of induction motor, and these motors are very cheap. So in industries, only 5 to 10% induction motors can be seen. That is, they are rarely employed in the industries. Around 95% squirrel cage type of motors are seen in industries. So around 5 to 10% only you can see the slip ring type of induction motor, because they are costly and the construction is complicated because of frequent maintenance. But here you can experience 90 to 95% squirrel cage type of motor in industries. And if you look here, for your slip ring type of induction motor, the rotor copper losses are very high, hence the efficiency is less in your slip ring type of induction motor. Here the rotor copper loss are less, that means high efficiency in your squirrel cage type of induction motor. And if we discuss the other differences, here we are having high starting torque, here the moderate torque, and we can reduce the high starting current through these external resistances, and the slip ring and brushes makes our slip ring type of induction motor costly, complicated, and frequent maintenance is required, and we are having rotor copper losses are very high in your slip ring type of induction motor, and that means low efficiency, and here we are having high efficiency. And if we find the application of this squirrel cage type of motor and slip ring type of motor, generally your slip ring type of induction motor are employed where we require high starting torque. So the application goes to hoist, In hoist we can use this hoist, cranes and lift where high starting torque is required, and these squirrel cage type of induction motor are used in lathe machines, drilling machines, blowers, fans, and printing machines, etc. Because of their high efficiency, cheap, simple and rugged type of construction, and no maintenance is required, and they do not have slip ring and brushes, and 90 to 95% they are employed in the industries. So this is the overall differences between your slip ring type of induction motor and squirrel cage type of induction motor. So I hope you have understood well. Please subscribe to the channel. Thank you.